Hello students, welcome to Soras's classes. In this video, I will be solving the following questions from ISS 2015 paper 2. Now in this question, we have to find out that for a completely balanced two-way random effect model, what are the unbiased estimators of different variance components? So if we have a completely balanced two-way random effect model, then what are the unbiased estimators of different various components? Now let us consider the model. So let us consider the model without interactions. So let the model be Yijk is equals to mu jk plus Eijk. So Yijk is equals to mu jk plus Eijk, where this mu jk, this is equals to mu plus alpha j plus beta k. So mu jk is equals to mu plus alpha j plus beta k. So from here we will get Yijk, this is equals to mu plus alpha j plus beta k plus Eijk, where this Eijk, this is a Gaussian error term. So it is a Gaussian error term, and this follows, and it follows normal distribution, that is Eijk. So this term Eijk, which is Gaussian error term, it follows normal distribution with parameter 0 and sigma square, that is mean 0 and variance sigma square, and they are IIDs, that are they are identically and independently distributed. So this Eijk, they are IIDs that follow normal distribution with mean 0 and variance sigma square. Now the component variance can be estimated by the following. First one is SST, that is the total sum of squares. So this is equals to summation k goes from 1 to b, summation j goes from 1 to a, and summation I goes from 1 to n. So here this j, it will go from 1 to a, and this k, it would go from 1 to so on till b, and this I, it would go from 1 to so on till n. So SST, it is equals to summation k goes from 1 to b, summation j goes from 1 to a, summation I goes from 1 to n, Yijk minus y bar double dot whole square, and the degrees of freedom, the corresponding degrees of freedom, it would be equals to a into b into n minus 1. So the degrees of freedom is a, b, n minus 1. Now next is SSR, or sum of squares due to residual, or residual sum of square. So SSR, this is equals to n into summation k goes from 1 to b, now summation j goes from 1 to a, then we will have this yj dot bar plus y dot k bar minus y bar double dot whole square. So SSR, or sum of squares due to residual, it is n into summation k goes from 1 to b, summation j goes from 1 to a, then yj dot bar plus y dot k bar minus y double dot bar whole minus y double dot bar and whole square, and the degrees of freedom, the corresponding degrees of freedom corresponding to SSR, it is equals to a plus b minus 2. So the degrees of freedom is a plus b minus 2, and SSE, which is error sum of squares or sum of squares due to error, this is equals to summation, again k goes from 1 to b, summation j goes from 1 to a, and summation I goes from 1 to n, then y I j k minus, then we will have yj dot bar plus y dot k bar minus y bar double dot, then whole square. So the first one is total sum of squares, total sum of square, SSR is residual sum of square, residual sum of square, and SSE is error sum of square, error sum of square. And the degrees of freedom corresponding to SSE, that is error sum of square, it is equals to a b n minus 1, then minus a plus b minus 2. So from here we can write the degrees of freedom is equals to a b n minus a minus b plus 1. So the degrees of freedom is abn minus a minus b plus 1. So these three are the unbiased estimator of different variance components.